When it comes to breaker sizing, there's something that I realized that most installers just size breakers for inverter based on how they feel or based on what is available in the market. Some even do it based on the previous installation. They use a past project to resize the same to a different project with the same breaker they use now. All those methods are literally wrong. So um this lesson we're looking at how to size our breakers the right way. And this will really help you because undersizing a breaker can cause overheating. It can make your wire not to trip off. It can make it not trip off. And if your breaker didn't trip off, it means it will damage your inverter. Or oversizing your breaker can make your wire overheat because your breaker didn't trip off. So in of those experience, we want to see how we can help you avoid those things. And that is the reason why this video will really help you on that. So a DC breaker is a protective device used to protect our solar panel, batteries, and inverters from overcurrent and short circuit. One thing you don't want to do is that you don't want to mistake a DC breaker for an AC breaker. And if you do that, is what the current is different there. The current for an AC breaker moves like a wave. Unlike a DC breaker, the current moves straight line in a straight line. So interchanging those breakers can affect it can make the breaker overheat and with no time it can burn. So the basic function of a breaker, and for this example, we're using a DC breaker, is to protect our cables from overheating. The other function is to protect equipment from excess current, allow safety isolation of our solar panel or batteries during maintenance. You can easily trip breakers off when doing maintenance. It helps prevent electrical fire caused by fault. A fault can happen, and if your breakers did not trip off, oh my god, it may affect the inverter and the damage can be very, very drastic. So, I love to use very, I don't know. So, knowing the correct breaker rating to use is essential for the safety of your solar system. So, this is how to size breaker the correct way. Um, Choosing the right breaker size is important for protecting your solar panels, battery cables, and inverter. The first thing to do is to determine the current. And we've done this many times. Current is equals to power divided by voltage and apply safety factor and select the next standard breaker sizing. So let's look at the first example that we have here. For a 3.5 kVA inverter rated 24 volts, the power 3500 watts, the voltage 24, that's 3500 divided by 24. That gives us approximately 142.8. Now, these amps increase because the voltage is very low, and this is to size our battery. So, uh, the right breaker size to use is to use the next standard uh, breaker sizing after applying safety factor of 25%. So the recommended DC breaker is 200 amps. The 200 amps can easily handle your 3.5 kVA inverter. This is a breaker that you use in between your battery and your inverter. So the next is our solar panel. And solar panel, to calculate the current, we need our panels to be in parallel connection. So assuming each panel IMP, that is the maximum power current, is 14 amps, and three panels in parallel will give us 14 plus 14 plus 14, that's equals to 42 amps. Applying safety factor to that will be 42 amps, or 42 times 1.25, that's equal to 52.5. Now, 52.5 is not a standard breaker size, so we have to use the next standard breaker size, which is 63 amps. So a 63 amps can easily handle these three panel arrays in parallel. So the example that we did have here is for our inverter, that's for our AC. So let's do that, and we don't have a slide to show on that, but let's see how we can do that. So let's use the example of our inverter, a 3.5 kVA inverter, still rated 24 volts. So for our 3.5 kVA inverter, we want to size the AC output, so or the AC input. So that will be 3,500 divided by 230. That's the AC, that's the output that comes out from our inverter. So 3,500 divided by 230 will give us 15.2. So uh, the right breaker to use there, 15.2 is not a standard breaker and we cannot use below that. The right breaker to use there is to use a 20 amp breaker, can easily handle this. Or if 20 amp breaker is not available in the market, then you can use the next standard breaker. So friends, this is how you can size your breakers the right way, so you don't have to keep guessing, you don't have to keep trying to see what did I use on the last job, because sizing breakers the right way will really help you, and it will make your work professionally. So you can try this with so many examples. You can try it with the 5 kVA inverter, you can try with the battery side, you can try with the inverter side, you can try it with the solar panel side. So this is how to size breakers the right way.